Hello, beta. Hello, 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 hello. Welcome back to my YouTube channel. Am I audible and visible to all of you? Am I audible and visible to all of you? Let me know in the comment box. Am I audible and visible to all of you? Hello, beta. Good evening. Hello, Hasna. I guess in the Telegram group now, I updated you regarding some health issues, right? Due to which I was not able to just start the class at 10:30. Yeah. Due to some family members health issue. No? I was in the hospital right now. I just came from the hospital and directly I started the kind of class for you. Before 2 minutes, I just came from the hospital. So that's why I just started class a bit late. I hope that you can understand. Now, 1 second. Okay. Am I fully audible and visible to you? Am I fully audible and visible to you? But what? I'm not getting this thing from my end. 1 second. One second, beta. Now. Yeah. So let's now start. Okay. So in the previous class, we completed solenoid one. Okay, the long solenoid, ideal one, finite one, and how to find the magnetic field in the middle of your solenoid and the end one. Okay, so we got to know that the relation between n and center. N means center half. Now in today's class, we will start toroid. Okay, now what basically is toroid? What basically is toroid? As we know from previous class, look now, this is my non-conducting base. Okay, if we are just taking a wire and placing in such a manner, okay, this in this particular manner, so this configuration of my wire known as solenoid. Now take these two ends, this end and this end, just connect these two ends. Let's suppose it is something like this. Now look, 1 second. Okay, this is my solenoid, right? Now I just take these two ends, now just connect them like this. Okay, so you will find a circular shape thing. Okay, you will find a circular shape thing. This circular shape thing is known as toroid. Easy. So this circular shape thing is known as toroid. So what I can do right now, I will just make the toroid now. It's my toroid. Look now, it's my toroid. Okay, now what I need to do, 1 second, I need to pull it up. Okay, now take my wire, okay, like this. One second. So this configuration of my wire is known as toroid. Simple. Current I is going inside and I is leaving. So this particular thing is known as toroid. This thing is known as toroid. Okay. Now we know that outside the solenoid, magnetic field is zero, only inside is present. mu naught Ni, right? And if we talk about this toroid, outside it is 0. Here inside it is also 0. But inside this it is not 0. So inside it is present. No? Here, look, here it is present here. Only inside the core material your magnetic field is present. Okay, so only here B is not equals to 0. Only here B is not equals to 0. Done? Very easy. You can also write that magnetic field is only present inside material. Okay, now what we know from this perspective, what is magnetic field equation? Sir, it is nu naught Ni, or I can write, sir, it is nu naught, in place of this small n I can write capital N by L dot I. Done? What is this n? Sir, number of turns. L, it is length of my solenoid. As you know that if we are just turning my solenoid into this particular toroid, this length I can write it as now circumference of circle. It is now circumference. What is the, if the radius is r? If the radius is r, so you can write L equals to 2 pi r. So therefore, for toroid, it is equals to nu naught Ni whole divided by, it is 2 pi r. This is my equation for toroid. Toroid is not important, but still you need to get it, right? In some cases, rarely, okay, it is some rare cases that you will get something like this. Look, if now in your examination, if R1 is given and if R2 is given, but here you can see only one R is here, no? So what you need to write, you will write, sir, R is equals to average R1 plus R2 by 2. You need to write like this. You need to write like this. Done? Now, up to this particular topic, what we had studied, sir, magnetic field around a current carrying wire according to the Biot-Savart law. Okay, nu naught I 4 pi I sine theta 1 plus sine theta 2. Then second case, if the wire is finite, then if the wire is infinite, then magnetic field due to the arc on the center, then due to the circle, due to a quadrant, due to a semicircle, then magnetic field on the axial line of a ring. Then, so these things we studied up to. Then we studied solenoid, different cases of it. Now we will start now second part of magnetic effect of current. Second part. So from today we will start the second part. Part second of my chapter, that is motion of charged particle. Motion of charged particle in uniform magnetic field, or you can also write that is force on a moving charge. Topic name is force on a moving charge, or you can just write as a Motion of charged particle in uniform magnetic field. A good topic, an important one. And if you want to write the equation for it, so it is very famous that force is equals to charge, then V cross B. This is my equation. It is in vector forms. Done. So F is force. F is force. Q means charge. Q means charge. V means velocity. Velocity. And this B means magnetic field. Magnetic field. It simply indicates that whenever my charged particle is traveling in magnetic field, the charged particle will experience a force, magnetic force. And to get the magnetic force direction, it is V cross B. To get its magnitude, it is V B sine theta. Now I will write that thing also. So if you want to write it as magnitude form, it could be equals to Q V B sine theta. So what is this theta? Theta means angle. Theta means angle. Angle between velocity and magnetic field. And magnetic field. So just one thing is, am I lagging? One thing. Okay, due to network issue, sometimes I'm just lagging, right? Okay. So whenever your charged particle is in motion in any magnetic field, it experiences a force, magnetic force, and its magnitude is QVB sine theta. If we talk about in a vector form, it is F vector equals to Q, V vector cross B vector. Suppose now you will tell me, sir, why the charged particle should be in motion? Okay. If let us suppose, I will write here, if V equals to 0, V equals to 0 means if we are talking about a stationary charge. A stationary charge. If we talk about a stationary charge, so I can write F equals to Q V B sine theta. Just place a value of V as 0, so I guess my force is 0. By this simple observation, we conclude that if the charged particle is at a stationary position, it doesn't experience any force due to this magnetic field. Okay, charged particle should be in motion to get the magnetic force. Okay, now in our examination, we are having some cases. If my theta is 90 degree, that means if the angle between my velocity and the magnetic field is 90. Second, if my angle is 0 degree. Third, theta, any angle. So you will get your numerical problem based on these three profiles. Okay, and this one is most important. Theta 90 degree, it is most important. So I can write here, this one is most important. Most important profile. Most important one. Okay, now let us discuss one by one. Let us discuss one by one. Why I'm just hanging? One second. Okay, now look, now let us start now with case number first. Case number first, that means when theta is 90 degree. When theta is 90 degree. So sir, how to represent it? Let's suppose my magnetic field is inside. This now cross means it is inside, into the plane. My magnetic field is into the plane. Okay, I can write here B is inside. It is inside. Now we are having a charge particle. Here is my charge particle plus q, plus q. Its velocity is in this direction. Velocity. Done? It is velocity. Take your right hand. Take your right hand. Just do V cross V. Just do V cross V. Take your right hand. Yes, sir. Place the right hand on the V. V. What is velocity is in this way? Yes. Now curl your fingers in the direction of B. Where is B? Inside. Where is your thumb? Upwards. So your thumb is upwards. So what I can write here? I can write here. Hello, beta. Samrat Samrat Gupta. Hello, sir. Please replay. What is the live session? Huh? I can just replay this one. Okay. Now, if we are placing the hand, look now. Take your right hand. Okay, place it on V. Curl your fingers where B is. Now, thumb will give direction of F. So you can easily get my F is in this direction. Force. Now, just extend the F. Extend this F. So my center will be here. Okay. Or if not here, so I can write here. I can write here. My center is here. But one thing is sure that my center will be on the force axis only. I will tell you the reason. Okay. Now, whenever force and velocity, whenever force is perpendicular to velocity, the path will be circular. You can see here, force and velocity is perpendicular, so the path will be here, what? A circular path. If we talk about this point now, if we talk about this point now, this point, okay, my particle will be go along this one. It is my velocity, this is my force. If we talk about this one, this is my velocity, this one is my force. If we talk about this point, this is my velocity, this one is my force. You can take 1 minute, just understand this particular point only. One second. Okay. Done now? Done now? So how to get direction? Take your right hand. Done. Now from this perspective, for this one, so you can write now, look, F equals to Q V cross B. So F is perpendicular to V and F is perpendicular to B. Why is that? Property of a cross product. Let us suppose A cross B is just giving you C. So therefore, C is perpendicular to A and C is perpendicular to B. According to this property, we can just conclude my force is perpendicular to my velocity and my force is perpendicular to my magnetic field also. Done? Now, theta is 90 degrees. So one thing that we know, F equals to QVB sine 90 degree. And we know that sine 90 is 1. So I can write F equals to QVB. Okay. Now you can see from this figure, na, your particle is doing a circular motion. Your particle is doing a circular motion. And which force is governing this circular motion? I guess this magnetic force. Due to this magnetic field force only, your particle is describing a circular motion. That simply indicates that my magnetic force that is QVB, okay, this force is giving you the providing you with a centripetal force if the radius is r. So I can write mv by r. So this equation is important. This one is important. Why, sir? Because by this equation we conclude that due to this magnetic force only, we are getting a centripetal force. That means a force which is responsible for the circular motion. So now if we are just focusing on this equation only, so I guess my r came out to be QVB divided by MV square. 1 we cancel out. So you can write a radius of my circular motion is QB by MV. Okay. If in numerical it is given that, let us suppose we are having a particle proton. Okay. And we projected this proton in a magnetic field, let us suppose 2-4 Tesla. Right, and with velocity 10 meters per second. Find the radius of the circular motion. So we have to use QE by MB. There are a lot of formulas also, no? What is this R? So you can write this is for a formula, a radius of circular path. Okay, one thing that you must know, that is MR, sorry, it will be MR by QB. MR by QB? Okay, 1 second. R MV square. Yes. 1 second, beta. 1 second. It would be R. Perfectly. It will be MV square by QVB. Cancel out. So we are having MV by QB. Thank you, beta. Thank you, beta. Okay. Now, do you know that what is MV? What is this MV? Momentum, that is P, which is equals to MV. One thing. Okay. What is kinetic energy? 1 by 2 mv square. Multiply with velocity, divide with velocity. I guess I will get, let's multiply it with mass and divide with mass. 1 second. With m, divide with m. So I will get m square v square by 2m. Done. So look, mv square, I guess it is p square by 2m. So kinetic energy is p square by 2m. Therefore, p square equals to 2m kinetic energy. So momentum came out to be under root of 2m kinetic energy. Done. Okay, one more thing, that is work done by all forces equals to change in kinetic energy. It is Q charge into potential equals to change in kinetic energy. If initially is zero, I can write it is Ke. Done. So now one more equation, P is equals to under root of 2m QV. Now place these formulas. Thank you, beta. Now place all these formulas in this equation. Okay, so one radius is equals to mv by qb, or I can write by this formula, it is p by qb. Okay, we can write P as a 2mk, right? I can write 2mke whole divided by qb. Okay. As per this formula, I can write 2mqv whole divided by qb. This V is potential difference. So these are your total formulas to calculate what? R, radius of your path. Done? Now, sir, what will be the time period? If somebody will ask you, what could be the time period? Okay, so I can write for time period, or I can write for time on. Okay, time. I guess time is equals to distance by speed. Distance is 2 pi r. Speed is v. Okay, sir. 2 pi by v. What is r now? What is r now? I guess r is mv by qb, right? I can write mv by qb. V cancel out, so it came out to be 2 pi m by qb. This one. If now we will find frequency. I guess frequency is nothing but 1 by time. I can write it is qb by 2 pi m. Okay. If now what is angular frequency? What is angular frequency? Okay. Again, that is omega, that is 2 pi f. It is 2 pi, f is qb by 2 pi m. 2 pi cancel out, it is qb by m. Okay. So this is frequency 1, time period, angular frequency. Done? Any issue with these things now? Today class is very important, no? It is very important because we are just we will complete maximum things. Okay, now one more thing. That is, we know that my force is perpendicular to velocity, and velocity is related to displacement. Clear? Velocity is related to displacement. So therefore I can write my force is perpendicular to displacement. My force is perpendicular to displacement. Done? Okay, so what is the usage of this particular point? Look, beta. One thing that you all know now, that what is work done now? What is work done? Sir, work done is equals to force dot displacement. This thing is displacement. Or you can write it is F S cos theta. Now we can say only now the velocity. Velocity is dependent. This thing is depending on the displacement. No? That means direction of your displacement and the velocity at a particular instant is same. In that perspective, we can call force is perpendicular to displacement. Now, what is theta now? If force displacement are perpendicular, so by this particular thing, theta is 90 degree. So can I write now here Fs cos 90, and cos 90 is 0. So therefore my work done came out to be 0. So this particular thing concluded that work done by magnetic field, or perfectly it is magnetic force, no? More accurately, magnetic force is always 0. So by this simple statement, you conclude that your magnetic force cannot increase or decrease speed of your particle. If your particle is moving inside any magnetic field, it will go with a uniform motion with same sort of speed, no alteration in speed. One more thing, do you know why? Look now, work done by all equals to change in kinetic energy. Work done is zero, so I can write zero kinetic in energy final minus kinetic energy initial. Therefore, I can write kinetic energy final equals to kinetic energy initial, which includes that my speed is constant. Speed is constant, but velocity is not constant. Do you know why? Do you know why? Because velocity is depending on direction, and in circular motion, direction changes at every point. Also, if we talk about the momentum, momentum is also a vector quantity. Momentum is not constant. Now, if we talk about power, power is work done per unit time. So power delivered by your magnetic field, work done is zero by T. So therefore, we can conclude that power delivered by the magnetic field is also zero. Okay. Okay. Done. So let us just think about some points or some situations, right? So let us suppose now, if we are having a magnetic field like this, if we are supposed to get a magnetic field like this, look now, this one is my magnetic field, this one is my magnetic field, and my charged particle plus q, my charged particle is in this way, and we just projected the charged particle inside my magnetic field. Okay, and it is not like here, it is here, na? Q plus q is here. Now, as we know that force axis will be like this, it's force axis, force. One thing is confirmed that center will be on this axis only. If this center now, okay, so it will go like this and then straight. Velocity final, velocity initial. This is my radius r. Done. So if we are throwing a particle, look now, if we are throwing the particle, Devanshu Raj, beta, I'm just teaching physics now. How do I know about chemistry, right? If you know I will just give you one clue. Now, if you know the basics of any chapter, then one shot is good. But if you don't know anything regarding any chapter, right, do from the basics. Look now. Now, if you are throwing the particle from the starting of magnetic field, if you are throwing a particle from the starting of magnetic field, it creates a path like this, a semicircular path. Why, sir? Because this path tries to change the position of your particle's motion, but at this particular point, no magnetic field is present, so no deviation or at all. Okay, so you can see my particle initially it is going in this way, at final in this way. Okay, so you can write firstly it was going in this way, and at the end going in this way. So what is angle of deviation? I can write angle of deviation. Angle of deviation. I guess angle of deviation equals to 180 degree in this case. Okay, beta. Then also here, if you can just do one thing now. Look now, if velocity initial is 10 meters per second, it will came out from the magnetic field with the same velocity. Why? Because we concluded right now, na? Why? We concluded from this particular thing that, well, okay, and the speed is constant because magnetic field or magnetic force work done in this process is zero. shunya, 0. Okay, let us suppose now one more case, different case. That means I will tell you how to find angle of deviation. How to find angle of deviation? So what is the meaning of it? Let's suppose this thing represents, okay, it's one shorter one. If this thing represents my magnetic field, okay, cross, okay, 3, and the width of my magnetic field is d. If the width of my magnetic field is d, then clear now? Okay, and d is small as compared to r. Now, look now. We projected my particle. This is my particle. We projected it in this way, velocity. So we know that a force will be in this way. It's my force, and the center of the circular path will lie on this axis. Okay. Now the particle will go in this way. Okay. Then here no magnetic field is present, so it will go straightwise. So initially you can see it is velocity in this way, and finally here, so this angle is alpha. So this angle is known as angle of deviation. Angle of deviation. Now you can see now. Look at this particular point here. Now I will just do one thing. Okay, I will extend this line now. This one now. This is my radius of my circular path. This one, a radius of my circular path. And you can see radius and velocity both are at 90 degree. This one is 90. If 90, so this one would be how much? This one, no? 90 minus alpha. So this could be alpha by triangle rules. This is 90. This is D. This one is R. Alpha. So what is sine alpha now? Sine alpha? P by H. P is D, H is R. So what is alpha now? Alpha came out to be, it is sine inverse D by R. Sine inverse D by R. So this alpha known as angle of deviation. This angle is known as angle of deviation. Done? This angle is known as angle of deviation. Simple, now? This angle is known as angle of deviation. You can just take a screenshot of this one, how we concluded the angle of deviation. And if you find any difficulty to get this thing, you can just let me know. Beauty of the online lecture, right? You can ask me your doubts if you are not clear with these things. I can just make you understand, no? By repeating these things a couple of times. Done? If now I will just, if it is clear now, then I will just ask you one numerical. Numerical is like, we are having 3 particles. We have proton. Second, we have deuteron. Why, beta? We are having deuteron. Then we are having alpha particle. We are with these 3 particles. We are with proton, deuteron, and alpha particle. We just throw these particles in same magnetic field. And with same energy. Then find a ratio of their radii. Okay, you will get a numerical in your examination like this. That let's suppose proton, deuteron, alpha particle, we throw them with the same energy in same magnetic field. Then find the ratio of their radii. Okay, sir. But we are having couple of formulas to get the radii. Now, which formula I need to use? Okay, we can write those formulas. I guess my formulas are R equals to mv by qb. Yes, sir. Which is equals to P divided by QB, which is equals to 2ME, right, divided by QB, root, which is equals to 2MQV whole divided by QB root. Okay, now, look, potential is not given to us this way. Yes, sir. So, we cannot use this one. Momentum is not given. We cannot use this one. Velocity is not given. We cannot use this one. Look, two constant, mass we know, energy we know, Q we know, B we know. That means we can use R equals to under root of 2ME divided by QB. Look, we can see now 2 is constant. Yes, sir. Energy is constant. Yes, sir. Magnetic field is constant. So can I write now R equals to under root of M by Q? Yes, sir. We conclude from this one. No? Then what I will write? I will write a radius of proton is to radius of deuteron, then a radius of alpha particle is equals to proton under root of mass of proton divided by charge of proton is to under root of mass of deuteron divided by charge of deuteron, then root of mass of alpha particle divided by charge of alpha particle. I know that you don't have many things, no? So I will just write here alpha particle, proton and deuteron. Proton and alpha particle. If mass of proton is mp, so mass of deuteron will be 2 times mp. Mass of alpha particle will be 4 times mp. Now charge. If charge of proton is qp, charge of deuteron is same, that is qp. Charge of alpha particle is 2 times qp. Now place these values. I can write under root of mp by qp. Then under root of md. md is mass of deuteron, that is 2 mp. 2 mp by then is charge of deuteron, that is qp only. Now qp is to mass of alpha particle 4 times mass of proton divided by 2 times charge of proton. qp cancel out, mp cancel out. So I guess my answer is 1 is to root 2. Then here it is root 4 by 2. Root 4 by 2 equals to 2 square root by 2. It is 2 by 2, which is 1. Therefore, my answer is 1 is to root 2 is to 1. This one is my answer. Yeah, doubly charged, or you can write doubly ionized helium particle. It is He2 positive or He plus plus. That means if we are extracting the two electrons from helium particle, it will behave as an alpha particle. Okay, easy. Now if somebody will ask you, find the relation of the time period also. Okay, now if somebody will ask you, find the relation of time period also, time period. So what is time period relation? Time period, is it 2 pi m by qb? Look, b is same, 2 same, pi same. I guess it is depending on q by m by q. So time period of proton is to time period of deuteron, time period of alpha particle. I can write mass of proton, charge of proton. Then mass of deuteron, charge of deuteron is to mass of alpha, charge of alpha. I can write mass of proton, charge proton. Mass of deuteron is 2 times mass of proton. Charge is same as a qp. Done. Then mass of it is 4 times mp divided by 2 times qp. QP, 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 MP, MP, MP. 2 ones are 2, 2 twos are 4. So my equation came out to be 1 is to 2 is to 2. This is my answer. Easy or super easy? Is this easy or a super easy thing? Huh? Easy now? Look now. Let us just do some numericals now. Okay. If we are having a charge is minus 2 microcoulomb. Done. Minus 2 and we are having magnetic field B, which is 2 Tesla, and it is acting along plus J cap. Along plus J cap, and my velocity is given to us. Velocity is 2 I cap plus 3 J cap. 10 to power 6 meters per second. Then find the value of F. Sir, it is simple, no? How? F is equals to Q V cross B. Done? Yes, sir. What is Q? Minus 2 into 10 to the power minus 6 coulomb. Okay, write it down. Minus 2, 10 to power minus 6 coulomb. What is V? V is this much. It is 2 I cap plus 3 J cap. Done? 10 to power 6. Then cross B. What is B? B is 2 plus J cap. Cancel out. Minus 2. Look, 2 I cap cross 2 J cap. It is 2I cross 2J. I can write 2 I cross J. I guess I cross J is plus K cap. I can write it is 2 to the 4. It is 4, 4K cap. It is 4 plus K cap. Then plus 3J cap. It is 3J cap cross 2J cap. 3 to the 6 is J cross J. It is J cross J. And J cross J is 0. I can write 0 here. 0 now. I can write 6 into 0. So look, it is minus 2, 4. It is minus 4 to the 8, 8K cap. Or I can write it is 8 minus K cap. This is my answer. This one is the answer. Easy or super easy? Easy or super easy? Yes, it is the final answer, but in a vector, it is minus K cap. That means it is beyond, okay, into the plane. Super easy, na? Okay, let us increase the hardness of numericals based on our aim, right? So, let us suppose now, we are having a wire, infinitely long wire. Current I is flowing and I is 10 ampere. Okay. We are having electron. Electron is here. Electron motion is 10 to power 5 meter per second. Done. And it is 2 centimeter apart from the line. Done now. Find force. Find force then. Okay. Sir, I guess force is equals to, it is Q V cross B. Yes, sir. Is it? Yeah. Force. Force. Q. If we talk about it is, I can add VB sin theta now. Okay. Look, electron is going in this way. It is velocity of electron. Now, take your right hand, place your thumb in direction of current. Yes, sir. Now, open your fingers in the direction of your electron. You can see my magnetic field is outside. So B is outside. That means B is in this way, outside, right? Force velocity is in this way. So angle is 90 degree. So I can write force came out to be beta QVB sine 90. I can write F equals to QVB only. Okay, F. What is Q? Q is charge of electron. 1.6 is 10 to power minus 19 coulomb. What is V? V is 10 to power 5. What is B? B is the magnetic field due to an infinitely long wire. It is nu naught I divided by 2 pi r only. Okay, I can write nu naught I. I is 10, 2 pi, R is 2 10 to power minus 2 meter. It is centimeter, so I can write 2 10 to power minus 2 meter. Done? Okay, now just open it now. F equals to 1.6 10 to power minus 19 plus 5. Okay. Nu naught means 4 pi 10 to power minus 7, 10 whole divided by 2 pi into 2 10 to power minus 2. 2 2 is 4, 4 4 cancel, pi pi cancel. So therefore, my force came out to be 1.6 10 to power minus 19 plus 5, then minus 7, plus 1, plus 1, it will go upside, then it is plus 2, plus 2. Done? 1.6 is into 19, 1 second. Look here, 5, 6, 7, 8. 8 plus 9, it is minus 1. 8, it is plus 1, plus 1 is minus 18. Minus 18, I guess, now. Is this my answer? You can just cross check it now. You can just cross check it, this one. Okay. Easy. You can just cross check it now. One more numerical. I will write the language of whole numerical. Whole one. Okay. A charge moving with velocity v in x direction is subjected to a field of magnetic induction in negative x direction. As a result, the charge will be, this is your homework, and I will write its parts also. Remains unaffected. Second one. Starts moving in a circular path of YZ plane, retard along Z axis, moving along a helical path around X axis. This one is your homework numerical. Okay. One last numerical for our homework, then tata, bye bye. Okay. This one is also a homework numerical. So ionizer hydrogen atom and alpha particles with same moment enters perpendicularly to a constant magnetic field. B. The ratio of their radii of their paths RH is to R alpha. We need to find this one. Okay, so done. So now, how many lectures we have done so far? 5 lectures. Okay, so I will try to complete the whole lecture within 3 days now. Okay, it will take more. It will take 3 to 4 more days. Okay, and I hope that you'll enjoy these sessions, right? I am giving you the all stuff, sir. That's why it takes so little time to cover the whole syllabus now. Okay, and if you find any difficulty and if you want to just let me know anything, you're most welcome. You can just comment below. Tomorrow we'll discuss these things. No? I know the answer. Okay, I know the answer, but you need to just spend some time. No? Okay, so thank you, beta. Thank you. Thank you. Thank you very much. Thank you. Thank you, beta. But be in the session, no? Just be in the continuous section, right? I guess I told you one thing, right? After completing the syllabus, I will just repeat this thing once again. After completing the syllabus, I will then start NCRT series in which we will be discussing each and every numeric of NCRT, unsolved and solved. Then we will start top 500 or top 1000 numerical series from particular lecture, particular chapter. That means we will start 1000 or a 500 top numericals from electrostatic, same 500 to 1000 numericals from capacitor, like then we will having the same thing from our current electricity and the magnetism, right? So in this way, we will complete the whole syllabus thrice. Firstly, by lectures. Second, by NCRT. Third, by these numerical discussions. Okay. And same we will be applying in our 11th class. Because you know that now within 1 month we will be completing the whole syllabus of 12. Then we will start 11th class one. So bye for today. Then we will discuss now tomorrow. Bye, beta. Thank you. Bye.